Okay, now let's solve this question using simple programming. Okay, so we have this question where we have given order size and discount, and there is some information to find EOQ, and basically we have to check the order size, different size, and find out where the least cost is. So determine the optimal order quantity and the associated minimal total cost of inventory and purchasing cost if shortages are not allowed. So we will check this also find at EOQ what is cost, and also find at these levels. Okay, so let's start. Now if you remember, in the last video we have already written a code, simple code for EOQ. Now we will just input values of this in that, and find out EOQ. So annual demand is 250 units, ordering cost is 20, carrying cost is 4. So let's input that. Okay, now in the last video we did this, right? So input annual demand to 250, ordering cost is 20, and carrying cost is 4. Okay, so economic order quantity is 50 minutes. So I press shift and to get output. Economic order quantity is 50 minutes. Okay, so now in this video let's write a code for using this information. Okay, so to find cost, now we need three things, right? Purchase cost, ordering cost, carrying cost. Okay, so what I am going to do, so first write the equation for cost. Okay, so cost will be what? Purchasing cost plus ordering cost plus carrying cost, right? Now let's write. So for this question, see, there is discount also, so we have to consider a variable discount. Okay, so it's also changing, it's not constant, so for different values it's changing. So this is the extra thing. Carrying cost is 20 per order. Okay, no problem. And carrying cost is 4 per unit. Okay, no problem. And EOQ is 50 units. Annual demand is 250. So first of all, let's write purchase cost. So purchase cost is like purchase cost. Our purchase cost is like depend upon our order. Sorry, not depend upon order, but it's we have given. Let's check out. I think I missed something. Okay, cost of single bearing is 30. So 30 times 250, right? 30 is per unit into 250. So purchase cost is that. So 30 times 250, and remember we are considering discount also, so it is going to reduce from this. So d percent. Okay, d percent plus ordering cost. So ordering cost is depends upon number of orders, so it will be our annual demand upon the size. So size, if it's EOQ then EOQ, and if it's these things then these things. So let's assume O plus, sorry, A upon O plus carrying cost. So carrying cost is 4 times it's on average inventory, so 8 times, sorry, it was like 4 na, so 4 times O by 2, right? Also I will just write annual demand value, it's same, so 250 times 250. Okay, so 250 upon O times, I think I forgot, times 20, right? So it's 20 na, 20 per order. So let's simplify this. So cost is finally 30 times 250, 7,500. Okay, now remember d percent. So instead of writing like this, we can also write, you know, so if discount is like 10%, so value will be then 0.90 of original, correct? So we can also write 1 minus t to get the new value after discount. That's what we want. Plus 250 times 25,000 divided by O, and then 2 times O. That's it. Now we have got this. Now just final job is to find where it's minimum, right? By considering various values. So why not do that like this? So for okay, so I'll explain what this means. So for O in range 0 to 1000, we will go up to 1000. Okay, if you do this by hand, you cannot do this. You can just calculate 4 to 5 values, but this is the real strength of the computer, that you can go from each and every value to compute the cost. Okay, so what this means is we are taking values of O, which is the order size from 0 to 1000, each and every value. So that covers our EOQ also and this also. They are not expecting us to do that, but we can just do this within a second and we can find out our answer. So let's do that. Now it's simple. So for O in range up to 0 to 1000. Okay. The next is to come to take. Okay. Now see, if the order size is from 0 to 49, then discount is 0%. So we will just write logic for that as if O is greater than 0 and O is less than 49, then do what? Then take D equals to 0. Okay, then take D equals to 0 and compute cost. Okay, now just copy paste cost. That's it. That's it, and we have to do nothing to change this. Yes, okay. Now remember this to multiply. Okay, now this we have to explicitly do 2 times O. Okay. Now if O is greater than 49 and O is less than 99, then set D equals to 0.05. That is 5%, and again copy paste. Yes, copy paste. You can see how fast and how quick this is. Again, if O is greater than 100 and O is less than 199, then set discount 10% and cost. That's it. If O greater than 199, then set discount as 0.12 and cost is. That's it. You can see how fast this was. And this is very powerful as it is enabling us to go from 0 to 1000. If you do this by hand, you can just do this is very mistake. You can do mistakes. Okay, you may not be able to do for more than 3 to 4 values, because see, you have to do for 50. Then suppose you decide to choose values like 60, 70, how much time it will consume, right? So I think that's it. So now I will just comment out this. Comment means the computer will ignore this thing because we want only this now. I think that's it. Now we'll just keep track of values of O. That means we will just do print O. That means we will come to know at which O ordering size it's lowest by this, and also I will print print cost to obviously come to know about cost at different, again copy paste. That's it. Okay. Oh, sorry about this. Oh, if you think, okay, now this was 4 times O by 2. Okay, sorry for that, and then it's like 2O, right? This was 4 into O ordering cost upon 2, so 2 times it cancels 2, so 2O. Okay, now I think this was mistake. Okay, 2 times O, 0, not a 0 O. So this here also I made mistake. That's it. Print cost. So I think let's run this. So shift enter. Okay, now, okay, so we have mistake, I think, here. Yes. Oh, hmm. Sorry, right. 7,500 into 1 minus t plus 5,000 divided by O plus 2 times O. Right? Okay, no problem. Yeah, sometimes mistakes happen. Division by 0. Okay, line number 11. No problem. Let's see. Mm, uh, cost is 7,500 into 1 minus plus 5,000 divided by, or this O and 0. So confusing. Instead I have written OC. That's it. You can see now at different values of order we have got the computer costs. So let's see. Okay, so it's increasing. Okay, decreasing. Let's see up to which it is increasing, decreasing. 7370. Okay, okay, let me correct it. Okay, let just me correct it. I will write here also equal to. So if O is greater than or equal to 100, and also here. Okay. Hmm. So decreasing, again start increasing. Okay, so somewhere here it's lowest, I think, at, okay, so at 100. At 100 it's 7,000. Okay, so at 100 it's 7,000, then you can see 101, then it start increasing. Before that also increasing. So that's it. It's our answer at 1,000. So order size not 1,000. Let me check. Sorry, 100. So at 100. So this order size is best. It's lowest. That's it. That's our answer. Answer is optimal order quantity 100 units, and the cost there is 7,000 only. So you can see how powerful this is. And if you actually check the solution in book, they have taken up to 250 only because of constraints. But I have done it up to 1,000 within a second. You can see up to 999. It has computed for us all the costs. So you can see how fast and powerful this is actually to solve, and within a second, and within 5 minutes, within 2 minutes, and do this. Okay, that's it.